This segment brought to you by Kansas Regenerative Medicine. Your stem cells, your health, your life.
In recent weeks, we've talked about Kansas State University's increasing role in agricultural research, featuring what are called Unmanned Aerial Systems, or UAS. On the strength of a multi-million-dollar partnership between Kansas State University and what's called the Plant Biosecurity Cooperative Research Center out of Australia. Now, the contact, if you will, and the lead here at Kansas State University in this project is with us now, K-State Research Entomologist Brian McCornack. Might explain what this center is all about and this partnership.
Sure, it's a little bit different funding agency in that it is an Australian government project. Well, there's probably about 30 organizations that are part of this Cooperative Research Center. But then also industry is the third partner in that.
Now, this is a 3-year, $1.74 million project.
Right.
And what K-State will be doing specifically here, you will be taking the technology to the field. And through your partners at K-State's Salina campus, which is proficient, to say the least, in this area.
All the safety precautions, this is exactly why this particular group is working with Dr. Kurt Barnhart and Mark Blanks, and I've got a half-time pilot that fits all those safety criteria that can essentially fly for us.
What you're hoping to do in a nutshell here as we get into the details is see what these unmanned aerial systems can provide in the way of crop pest detection in the field.
What we want to be able to do is see whether or not taking an unmanned aerial system platform and comparing that to the way we kind of regularly do surveillance. And surveillance, and all we mean is looking at that same field through time to see if there's any changes, something we need to take notice of, and using the technology to help streamline that process. Can we make it more efficient? Part of what our project is geared at is, can we at least find even areas where we should deploy UASs? So yes, they could be time saving and all that. Now you have that image, what do you do next? Do you find areas in the field that look like hotspots for insects? If that's the case, then we might want to deploy multi-rotor UAS, where it might only last 20 minutes in the air, but you might want to then deploy it to certain parts of the field to do more refined imaging. How do we use the UAS to understand its spread, its movement, how the populations build up, and can we detect that in areas where we haven't detected it before? So how do we get that data, make sense of it, and then when we fly it into a new area that might not be infested or infected, how do we then determine where to spend more time?